All right, so I want to go over a couple of problems that some of you had asked about, and I know this from these problems 11 and 15 from page 340. I have a note here to go over these, and I just completely forgot about it, so I apologize whoever asked about these type of problems from section. I think it was I don't know. I want to say like 5.2 maybe. So anyway, I'll go over them now, and hopefully it will help you to understand what's going on here. So when we have something like this where we have a single number or variable on the denominator, we can split this up. So this is the same thing as saying the integral of x squared over x minus 4 over x. Okay, and then all of this is in parentheses or brackets or whatever, dx. So x squared over x, we can simplify that. Okay, x squared over x is just x. So the integral of x minus 4 over x. So what we're going to do is we're going to look at these just like when we did derivatives, just like when we did limits. We look at these two integrals separately. So the integral of x gives you x squared, so add 1 to the exponent and then divide by that number. So we're starting out with a 1. So we add 1 to this to make it a 2, and then we divide by that number. Minus 4 is a constant, so I can take a 4 out, and then I'm left, 4 over x is the same thing as 4 times 1 over x. So we can take that 4 out, and then the integral of 1 over x is just ln of the absolute value of x. Okay, now we don't have any numbers on the integral, so we need a plus c. So this is your final answer for number 11. Number 15 is a little bit more complicated, but it's still something that we can do. So under the kind of the same idea here, if we were to look at, let's say if we wanted to do u sub, and we say, well, I know x squared, if I do the derivative of x squared, I'm going to get x. So, let's see what happens here when I take the derivative of this, and I say du is equal to 2x minus 3 dx. The problem here is that we cannot change this to be like x plus 1. Okay, so then our other option is to set u equal to our denominator. So let's try that and see what happens. So u is x plus 1, and then du is equal to dx. Okay, now you might be saying, well, that doesn't really help because this is going to be the integral of what, x squared minus 3x plus 2 over u, and the problem here, and then du. The problem here is that we have x's in here, and that's not okay, all right? We can't have x's there. But I can take this and solve for x and say x is equal to u minus 1. Then I can take this and plug it in here for all of these, or both of these x's. All right, so I end up with the integral of u minus 1 quantity squared minus 3 times the quantity u minus 1 plus 2, doesn't really look like a 2, plus 2, all that is over u, du. Okay, and I know I had mentioned this and we had talked about this before. I think I did problems of it. If I didn't do problems of it, let me know so I can go over some more examples, because I don't really remember. It was a week ago or so. But anyway, we can do this now. So we have the integral u minus 1 squared is u squared minus 2u plus 1. Distribute the negative 3 through, so we have negative 3u plus 3. And then I got a plus 2 out there, so plus 2. Okay? So, oh, and this is all over u. So I was just looking at my notes and realized I missed that 2 in my notes, so I had a plus 4. So I'm going to have to fix that. But anyway, so let's clean this up now. Integral of u squared, I got a negative 2u and a negative 3u is a negative 5u. I got a 1 plus a 3 is a 4, plus 2 gives me 6. All of this is being divided by u, du. All right, let me get a few more pages here of work. So now we're going to do just like we did in that last problem and just separate these. So integral, I'm going to skip the step of writing it out and just do u squared over u is u, minus 5u over u is 5, plus 6 over u is 6 over u, du. So now I'm ready to do my integral. So the integral of u is u, doesn't look like a u, let me fix that. The integral of u is, because this is u to the first power, will give us u squared over 2. The integral of 5 would be 5u, plus, and the integral of 6 over u is 6 ln absolute value u. And again, we need our plus c. All right, now we want to put this back in terms of x, so come back up here. U is x plus 1. So I'm going to take that and plug that in there for u in my last step. So I have x plus 1 squared over 2 minus 5 times u is x plus 1 plus 6 ln absolute value of x plus 1, which we still need to have the absolute values there because x could be a negative number, so we need to make sure we leave them there, plus c. All right, so that is your final answer there for number 15, okay? And again, that's probably one of the more complicated use substitution problems that you have to do. So yeah, there you go. All right, the last one I want to go over is one from a couple of days ago, and so somebody had asked about this one, so I wanted to go over it. Now, this section, it was like maybe 27, 29, 31. There was 3 or 4 problems that had problems similar to this one. So, but again, we're going to start on the inside and work our way out. So, arcsecant of x over 3. Well, again, if I have a variable in there, there's no way for me to be able to figure out what the angle theta is. But that doesn't stop me from filling in the sides of the triangle. If you remember, arcsecant is hypotenuse over adjacent. So we fill them in. This is hypotenuse. This is, down here is adjacent. Okay, so the hypotenuse we know is x. And the adjacent side we know is 3. I need to know this side over here. So we just use Pythagorean theorem. So 3 squared plus question mark squared equals x squared. Okay, so question mark squared is equal to x squared minus 9 when I move the 3 squared over. And then take your square root. So we know question mark is square root of x squared minus 9. Now don't make the mistake of saying that this is x minus 3. That is not true. We can't take the square root of each of them individually unless they're being multiplied. But if they're being added or subtracted, like this one is here, we can't do the square roots individually. All right, so this is the square root of x squared minus 9. So coming back in here, now we're looking for tangent. So tangent, I know, is opposite over adjacent. So my opposite is square root of x squared minus 9 over my adjacent is 3. And that is your final answer.